Alright, so today we're going to be working on the NCBI GEO database, and specifically how to get data from the NCBI GEO database, how to download, access, and prepare that data to be in a usable form. So first we're going to go here to the NCBI website, go to all databases, and scroll down to geodatasets. You're going to want to click on this. Then here, I'm going to copy and paste in the accession number, but the accession number, as you can see, is this, GSE 29265. That's all. So I copied and pasted that in. You can do that normally when you're trying to find something with a specific accession number. You just copy and paste the number in here, and then you'll be able to hit the search button. Search. You see this top result here. We're just going to click on it, and you can just scroll to the bottom and click on this HTTP to download it. I'm not going to do that now because I've already downloaded this file a few times, but if you need to download, just click on this and it'll automatically download. Now, once you've done that, once you've downloaded your file and you've got the data in your computer, you're going to go to your R coding. Now here, this is the R code we're going to use to transform that data into a more usable state. Now, if you need the BIOC Manager, AFI, GeoQuery, you can use this commented out code to install that. If you already have that installed, you just start by running the libraries here. So we're going to run AFI, GeoQuery, tidyverse. Now we're going to get the files. So this is the file that we just downloaded, GSE 29265, and we're going to essentially get that into, we're going to essentially say that this is the file that we're working on in this code. That's basically what this line says. It says, this is the file we're working on. Don't do all of this stuff to any other file except for this one. So I'm just going to run that. As you can see, there are a few different files because I've downloaded that file a few times, but if you've only downloaded it once, there should only be one file. Now, we're going to untar the files. As you can see here, it says GSE 29265 raw.tar because this file is in tar format, and if it's in tar format, you can't really open it. So for step one, we have to untar the files. Basically extract the data from the tar format and move it into a cell format. You can do that by running this line of code here. So I'm just going to run that. Now it's been run, and we can probably find that in our downloads. Go to downloads, go to this folder here. Normally it won't be in a folder, but I've already done this before, so I've already put it in a folder. So here it is. Click on it. As you can see, all of these cell files are data that were in that tar file. But now that we've untarred it, it's now spread across these various cell files. So next, we have to read in the cell files. You can see here. And we're going to do that by using read AFI to read in the cell files in this folder, raw data folder. That's why we put it into a folder, because if it's in the folder, so basically that's why we put it in the folder, so we can get all the cell files together. You don't really need to do that, but it just helps keep everything organized. And we're going to read everything in and assign it to this variable, GSE 29265 raw data. So we're going to run that. Now we've read all those in. Now we have to normalize the data. Normalizing the data is really important because it makes sure that you can really tell the difference between gene expressions, between the gene expression for one specific gene under different conditions. So basically, you really want to normalize your data by gene when you're talking about this kind of gene expression data. So and this is what it's going to be. It's going to be basically the normalized raw data, and it's going to be stored in normalized data. Next, we have to retrieve the expression estimates. So for normalized expression, we can retrieve the expressions for normalized data just by running this. Oh, and also, just so you know, you can totally get the normalized expression, normalized data, normalized expression. These are both here. Oh, but first we have to convert the normalized expression to data frame. So I'm just going to run that. Now we have the normalized data. We have a data frame version of normalized expression. Let's look at normalized data first. Just going to click on this here. As you can see, everything is in a bunch of basically sub-files. You can't really look at everything all at once, which is part of why we got that normalized expression thing. So we can have, slightly easier way to look at things. Here is the normalized expression. It's slightly easier. It's in a data frame, and it's in data frame form, and it's all set up so that you can really see all of the expressions levels there. Now we're going right back here, and next we have to map the probe IDs to gene symbols. Now here we're going from the normalized expression back to basically the data. And we're going to use two features of the data, which are probe IDs and gene symbols, and we're going to map those to each other because those are the two features we really care about for the feature data in this little project. We're going to run that. I want to just ignore this. I had to put that in just to try and figure something out. Didn't really work, so I commented it out. It's not really important. So that's been run. Now this is stored in GSE. So let's just open up the GSE right here. As you can see, it's all set up in these kind of like sub things. So you can't really see everything, which is why we're not done yet. Now we have to fetch the feature data to get the ID gene symbol mapping, right? Now we have to fetch this and put it into the feature data. All right, let's try that. Now let's see if we have a feature data. As you can see, it's right here. Let's click on it, and here is the big table of all the feature data. It has features up here, and it has the specific genes down here. And as you can see, you got everything you need. And as you can see here, probe ID right here, column 1, and gene symbol ID right here, column 11. So those are two of the features that we're going to be focusing on. So we're just going to go back here. Now, we already put this into the data frame here, but now we have to get the subset, specifically the subset of the probe ID and the gene symbols, and put that into a new feature data. It's called the same as the first feature data, which is a little confusing, I realize now, but this is just feature data 2 and this is feature data 1. So we're going to put this new feature data back into this old feature data. This old feature data into this new feature data, sorry. And we're going to do that by pulling out columns 1 and columns 11, because like I just said, the probe ID is in column 1 and gene symbol is in column 11. So we're pulling those columns out. So we're going to run that. And now we've got that. Let's go to feature data, see if it's any different. Yep, and here you go. New feature data, just got the 2 columns. Now, next up, we're going to go into normalized expression. Unfortunately, I did do the same thing here that I did for feature data, which is I've made the new normalized expression the same name as the old normalized expression. So just to show you what's going on, let me click on the old normalized expression to show you what it is. This is the old normalized expression. The numbers down here, the file names up here. Basically, what we need to do is flip the file names and the column names using the probe ID. So I'm just going to run this. It's actually making row names to columns and just making the whole table just a little easier to understand. So we just run that, and let's see if that worked. Oh, nope, did not work. Oh, let me see if I can try this again. For some reason, sometimes it does this. I'm not really sure why. Yep, there we go, all set. Okay, so that should have worked. So let me go back to the normalized expression. Yep, and here we go. ID is right here. And it's a little better because, it's It's the ID of its own row, and everything's numbered 1 through so on, and the ID is in its own column, so that everything is a little bit neater and easier to understand. And there we go. That's all the code you really need. And now you have your feature data with the 2 columns that you need, probe ID and gene symbol, all set. And you have the normalized expression with the probe ID in it. And so that shows you the gene expression of all of the genes. So you've got pretty much everything you need to do some analysis and research. And that's all you need to do. The end.